But compilers and IDEs came in with a bundled MISRA C checker. For example, in the E-squared Renesas Eclipse-based IDE here, you will go to Properties, and then in the compiler section, you can see that it has a MISRA C rule checker. But the question that you need to ask here is, how far is its MISRA C rule checker static analyzer goes? Now, in this IDE here, I also installed the Parasoft plugin. Here you can see the Parasoft menu. And with this configuration of this Parasoft plugin, you can see that it contains 5,000 static analysis rules. And that includes the MISRA 2012R, its latest revision now, which is named as MISRA C 2023 is called, containing 381 rules enabled. Now you might think that I have a compiler and it already does MISRA check, but that is a dangerous comfort zone to falsely believe that the built-in MISRA C checker of your compiler is enough. It gives you a false confidence that your code is okay, when in fact, it is not. So this is one of where the Parasoft positions itself as a very robust and complete MISRA C C++ static analyzer. Now, to show how the comparison of the behavior of these two static analysis, I will do the compilation very minimal in the command line. So the code that we're going to examine here is this one, p.c. It's only one file. That file is p.c. And this is the content of that file. This file compiles without any errors. But as you can see, obviously now here, it has a very nasty bug. The array here of 100 bytes can only accept an index of 0 to 99 because C array starts from 0 index. However, when you access the array here, the second parameter of the field array function, the size is 100. And because of this comparison in the for loop here, the 100 value that is passed becomes indexed into the array, and which is an out of bounds. An array out of bound access. Now this bug is very, very dangerous because it goes unnoticed silently. Your program will compile without warning. It will even execute without any errors. But deep inside, there's already a disease, a rotten disease, a defect deep inside the code. It's just not detected, and it will become an entry point for security vulnerabilities. Alright? So, some compiler claims to do MISRA C, but actually compilers, even from the GCC traps, the static analysis is not their primary concern. They have a lot of plates to take care, and static analysis like MISRA evaluation is not their priority, and this includes the Renesas ccrx compiler. Now let us try to analyze this code using first the Renesas compiler. I'll switch here to the DOS prompt, and then I already pasted the code here, and let me run it. So we will be using the ccrx here. This is the Renesas C C++ compiler. If you install the IDE, you will have this compiler, ccrx. I set this in the fast environment variable, so it's now accessible here in my prompt terminal. And all of these are standard. I copied it from the IDE. And then I write the object file of the compilation here. And this is the flag where I want to enable MISRA 2012, all of them. And this is the input file. I will now press enter here. And if we go to the code here, here, so we can see the object file generated, and this is the title of this recording here. The object file has been generated, and these are the MISRA static analysis validation. But nowhere in this report here is the array out of bounds, which is a part of MISRA rule, is being reported. Well, the thing about MISRA is it composed of a rule and a directive, but this compiler vendors are not very religious in completely implementing most of these rules, simply because these rules are very complicated sometimes. And this is the reason where a dedicated, the robust third-party static analyzer comes into play, like the Parasoft. Now, this is the compilation of the code, and this is the static analyzer as reported by the Renesas. It is now compiled again using Parasoft. So the Parasoft CLI can do that is the ccrx CLI. So I will do that here, and I will compile it now. Here, so same, we compile the P.C, and then this is the MISRA rule we're telling it to statically analyze. Press enter. Then, so it's printing some reports, but the output of that can be in JSON or HTML, which is here in the reports folder, HTML summary. We will open this HTML now here. So I will go to Renesas, and this is the folder that was just created, and this is the report HTML. And then this is the findings of static analysis by Parasoft. You can see bounds. I will search the word bound. And here, accessing an array out of bounds, which is this MISRA rule here, is reported. And this is this part here, where the index is 1 byte overboard of what is rightfully allocated for an array. It is an access out of bounds. It is not detected by the built-in MISRA checker of Renesas, and I believe this is also true for other compilers who claim to do MISRA check. Again, for the simple reason that these vendors do not prioritize a robust MISRA checker. They just do the basic stuff. However, you can see here in the Parasoft tool, it is only dedicated to robust MISRA analysis, and that includes a check of an array out of bound findings. See here. So, that's it, guys. Thank you.